Household electrical. Put it in your notes. Household electrical. We are continuing with electricity, but instead of using a CK12 lesson for today, I figured I'd just talk at you about household electricity. So here we go. Types of electrical in your house. You might have something that looks like this. It's got a little door on it. You ever seen this? You pull the door and it opens up. It's gray, right? And what's inside there? It's your breakers. Yeah, your circuit breakers. So if you open up that door, you'll see a whole bunch of circuit breakers. And they look like switches, right? And then at the bottom, you'd have like, bottom or top, you'd have like the main. You ever seen that? Look, open it up one day and just take a look. It'll say main breaker. And if you flip that to off, it turns all of the breakers off. Your whole house, all the power would be off. That's the breaker you should use if you don't know which circuit something's on and you are replacing it. Does that make sense? So you don't get zapped. Yes? Okay. Anyway, each of those breakers is going to be labeled with a number, okay? And it might be like 15 or 20, or you might have a 30. You might even have like a 50 in there, or a 40, okay? Most of them are going to be 15s and 20s. Does anybody know what that means? Not the watts. Close, though. Last one. Amps. You're just dancing all around it. And they're all connected, right? In fact, they're all connected by this formula right here. Watts equals amps times volts. If you didn't already I think you already put that in your notes. But if you want to put it in there again, a different spot, or just take a mental note of it, to find out how much wattage or electrical power you're using, you take amps times volts. Okay? So a 15 amp circuit in your house. You guys know what a circuit is? A circuit is like a loop of electricity, okay? And along that loop, you'll have your plugs, you'll have your light switches, everything you're going to use from that circuit. And each circuit has a certain capacity, okay? So if you have a 15 amp circuit, what that means is it has 15 amps of electrical current that can flow through the wire. I'm going to come way over here on the same line, and it uses 14 gauge copper wire as the conductor. Okay, put that in your notes all the way on the end. You can wait if you want to, because I'm going to put stuff in between there. So a 15 amp circuit uses 14 gauge wire, which is fairly thin, kind of nice and flexible, easy to use. It's used for things like lighting. So a 15 amp circuit is light duty. And I'm going to put quotes around light because often they're used for lighting. But you might also see them in places like living rooms, bedrooms. You'll often see them in bathrooms. And you'll even find them in kitchens too. I don't like that personally though. I prefer 20 amp circuits in kitchens, just personal preference. Okay, 120 volts. 120 volts is the voltage that goes in both 15 and your 20 amp lines, your 20 amp circuits. So make that note over there. 20 amp circuits are medium duty. And they run a 12 gauge wire, so a little bit thicker. So as the numbers go down with gauges, the thickness goes up. Does that make sense? Anybody ever fired a shotgun? Raise your hand. Shotgun? A few of you? Oh gosh, over half of you. A 12 gauge is heavier than a 14 gauge, yes? Anybody ever fired a 14 gauge shotgun? Is that a thing? Is that even a thing? I'm pretty sure that's a thing, isn't it? Or is it 20 gauge? The really small ones? Aren't they like 20 gauge shotgun or something like that? 12 gauge is heavier. Same thing with wiring. The lower the number, the heavier the wire, thicker the wire. So it can handle more current. So 20 amps is more current than 15 amps, so you got a heavier wire. Does that make sense? Okay. Now let's look at capacity. 120 volts, look, amps times volts gives us watts, right? With your calculator, go ahead and in your notes, write down how many watts each capacity is. Watts cap for each. You can put that in your notes. Everybody go ahead and do that, and I'll ask in a moment, what did you get? So amps times volts gives you watts. So we have 120 volts for each of these type of circuits, 15 or 20 amp circuits. So 120 times 15 will give you the watt capacity of a 15 amp circuit, how much power you could actually use, and 120 times 20 for 20 amp. Did you get it? You need a calculator? You don't need a calculator. You can do it by hand. You guys want to do it by hand? 120 times 15. What's 5 times 0? What's 5 times 2? 5 times 2? 10. What's 5 times 1? Plus 1. What's 1 times 0? 0. What's 1 times 2? 2. What's 1 times 1?
1.
Hey, you got that one. And what's 1200 plus 600? 1800 watts. 1800 watts right here. That's maximum. Okay, what does that mean? Well, it means, let's say you're in your bedroom. How many of y'all have a TV in your bedroom? That's terrible. Terrible. You can't sleep that way. How many of y'all actually leave it on and fall asleep to it? Ooh, that's really bad. But I mean, as long as you're sleeping, I guess. How many of y'all have a space heater in your room? I'm told that's dangerous, but sometimes you got to do it, right? Let's just say, good. So let's say, Thomas, you're running your space heater on full blast. Let's say it's 1,000 watts, okay? Which is not excessive. I've got a space heater in our living room right now that we plug into our solar wall. But anyway, and that can pull as much as 1,500 watts. So 1,000 watts, not crazy for a space heater to be able to pull. And for a bedroom, that's probably appropriate. So if you've got 1,000 watts already, how many do you have left on your breaker, on your circuit? 800 left if you're on a 15 amp circuit for your bedroom. Okay, well, let's say you have, you're in there and you're watching TV and you got the light on and you got a fan on, and what else might be going on in there? I don't know. Oh, ooh, this is perfect. So you've got your space heater on, you got your TV on, the lights on, and you're trying to watch your favorite show, and who other than Mom comes in your room, plugs in the vacuum cleaner. Never happened. Do you vacuum your own room? Okay, so you are like, I'm cold, I got the heater on, by golly, and I'm going to vacuum my room today while watching TV. So you got all this stuff on. I'm just going to make up, no, I'm not going to make up a number. I'm going to actually look it up. So let's look it up here. In fact, go ahead, if you've got your computer open. I got two people with the computer open. Google amp, or how many amps, I'll pull this over to the screen here so y'all can see. How many amps does an average vacuum cleaner use? There it is. How many amps does a typical vacuum cleaner use? Between 8 and 12 amps. So let's say it's on the low end. Let's say you got the cheap knockoff variety, right? You don't need anything crazy for your house, right? Well, if it's 8 amps, how many watts is 8 amps? You got a calculator? Amps times volts gives you watts. So if you got 8 amps and we're running on a 120 volt circuit, what's 8 times 120?
960.
960 plus your 1,000 watt heater, guys.
That's more.
It's over the capacity. We're not even talking about the fan or the light or the TV.
Firstly, I never have my lights on.
Okay. You'd still exceed the capacity, wouldn't you? So what's going to happen to our 15 amp breaker in the breaker box? What's it going to do? It's going to what?
It's going to turn off.
It's going to turn off. It's going to trip. It'll trip the breaker. So those circuit breakers are designed, once the current flowing through them exceeds their rating, they trip it. They break the circuit. It's a switch. Okay? It breaks the circuit. That's why they're called circuit breakers. So then you're like, oh, gosh. So you go, you find which one's flipped or tripped, and you turn it off, and then you turn it back on again, right? But if you didn't turn anything off, or if you go back to your room and you turn everything right back on, what's going to happen again? You're going to trip it again. Okay. So I'm going to tell you a historical fiction story, okay? Historical fiction story. So this is something that didn't happen, but it probably did lots of times with slightly different circumstances. Before we had circuit breakers, we had, instead of breaker boxes, we had fuse boxes. Anybody ever heard of a fuse box before? We still have fuse boxes commonly in like vehicles. But before there were switches, breakers in the electrical panel, there were fuses. Now these fuses were, they almost looked like batteries, kind of, sort of. But they were designed to go in and connect to each side, I guess the electrodes, right? Each side, your hot and your neutral. They'd slide in like a battery would in your electronics, and they'd connect them, and if the current flowing through exceeded the rating of the wire. So for example, if you're on a 15 amp breaker, or 15 amp circuit, excuse me, you'd have 14 gauge wire. Well, 14 gauge wire can only handle a certain amount of power before it starts to heat up too much. Does that make sense? It'll provide enough resistance to the electrical flow that it'll heat up. So the fuse was designed to melt, and then you wouldn't have a connection anymore. There would be a gap. Enough of a gap that electricity wouldn't be able to jump it. Does that make sense? We talked about arc, right, already. So the homeowner, let's say they had stuff plugged in like Thomas did, and it exceeded the rating of the fuse and of the wiring. And they take this fuse out and they go, oh, stupid fuse, blew another fuse, oh, and they chuck it because they don't understand electricity. Do you think there might have been some people in the 1930s, 40s, 50s that didn't quite understand electricity?
Yeah.
We have a lot of people now that don't understand electricity, don't we? Absolutely. Probably more now than then. But they take the fuse out, and if they didn't have a replacement readily available, now I heard this story. I don't know if it's 100% true, but I heard this story. That's why it's historical fiction, right? Something like it could have happened. I'm told that the fuses of a certain, I don't know if it was the 15 amp circuit or the 20, whatever it is, were the same height as a penny on edge. Well, before like the 60s, I want to say, before the 60s, pennies were 100% copper. Now you've got a penny is copper lined and there's just junk metal in the middle. Are you guys aware of that? Pennies aren't made of copper, just the film on the outside. Well, they'd stick a penny in there to restore the circuit so they could use it again. Will pennies perform like a fuse? Will it melt and break the circuit? No. So you'd have people putting a penny in there so they could go back to what they were doing. Well, what they were doing was exceeding the rating of the circuit, right? That's why the fuse burned out. So if they exceed what that gauge wiring can handle, too much resistance for how much electricity is trying to flow through the line, what's going to happen to the wire?
It gets too hot.
It gets too hot. It starts to do what to the insulating the insulator around it, the jacket around it. It starts to melt it, starts to smoke, and eventually where there's smoke, there's fire. So and it's even worse, guys. So back in the day, they'd take it's a cloth that they would wrap. They'd have the rubber insulator on the wire, and then they'd have a cloth wrap around that. I've replaced some of it. It feels like, I don't know if it is, but it feels like tar, like a tar paper wrap or something. Not exactly inflammable. So if it gets out of that, it's going to catch. And then, what did they used to use for insulation in houses? Depends where you were. But they used to use like cellulose insulation, which is flammable. Even our modern fiberglass insulation is usually at least somewhat flammable. So, you have a house fire. Okay, you guys understand the purpose of a circuit breaker is to break the circuit, right? Okay. Let's do the same. 120 volts times 20 amps. What would be the rating in wattage for a 20 amp circuit? Super easy math. 2400. Put in your notes, 2400 watts. So, and I didn't write it down yet. Here we go. For your 20 amp circuits, that medium duty, you're going to find that in like, I had bathrooms already here, but I don't know about you, but when the ladies in my house go in the bathroom, they have like a curling iron going, and then they have a hair dryer going all at the same time. And then, has anybody ever tripped the breaker in their bathroom? You're nodding your head. Yeah, guilty. So you might find 20 amp breakers in bathrooms. 20 amp circuits. Kitchens. Has anybody ever been in their kitchen and they had like the toaster going and maybe a coffee pot going? You're nodding your head. So you've had the kitchen trip. Okay. How about garages? Okay, so I had, yes, did that ever happen to you out in the garage? And it drives me nuts because I was in a brand new house, well, several years ago, and I was in the garage, I was plugged into the garage, and I was using a circular saw. Not a super powerful one either, just a normal circular saw outside with an extension cord. And I was in the middle of using it, been working, and all of a sudden it stopped working. So I went to check, and the breaker had tripped. So I went in there and I'm like, it's a 15 amp breaker that tripped. I'm like, well, it's 15 amp, but I'm still just using a circular saw that was below that rating. So I was talking to my wife later, and she says, oh, I had turned the garbage disposal on in the kitchen. Like, whoever designed this house had the kitchen garbage disposal on the same circuit as the garage downstairs. Anyway, so you can prevent some of that if you're going to be running heavier duty appliances. You know, whoever's designing the house, like, give it some forethought. If you're in a garage, is that where you're more likely to use heavier duty tools? Probably. Run a 20 amp line. What?
The kitchen is upstairs in your house?
At the last house, yeah. The kitchen was upstairs. Downstairs was like a basement area and a two-car garage. Really nice house. I just couldn't afford it. Had to get out of there. Okay. And heavier wire too, right? 30 amp. 30 amp circuits. How about, and by the way, this is getting heavy duty, right? How about things like clothes dryers? How many of y'all have an electric clothes dryer? Got that big honking plug, right, that goes in the wall? That's a 30 amp line, most likely. How about water heaters? How many of y'all have a water tank, like a 40 or 50 gallon water tank in your house somewhere, maybe in a utility closet or something? Yeah, that's most likely on a 30 amp circuit, a dedicated line. Like the only thing that serves is that water heater. Same for the clothes dryer. Trying to think what else for a 30 amp. 30 amp. Oh, out in the garage, maybe an air compressor. So if you have one of those big stand-up air compressors, anybody out in the shop maybe, in the garage, big stand-up, with a big old compressor unit on top of the tank, that's probably running on a dedicated 30 amp line, probably. 40 and 50 amp. 40 to 50 amp, depending. You're gonna have things, oh, by the way, 30 amp could be, anybody have a small welder? Like a small stick welder or something? That'd be on a 30 amp. A small welder. 40 to 50, big one here, folks. How many of y'all have an electric stove or oven in the kitchen? Electric, yeah. A stove. Probably on a 40 or more likely a 50 amp circuit, dedicated again. It's the only thing on that line. What else? If you have a heavy duty welder, it'd be on a 40 or 50 amp line. Instant water heaters. Anybody ever heard of a tankless water heater? They use a lot more power in the moment because they don't have a tank to like heat it slowly over time. So you might have two 40 or 50 amp breakers dedicated to an instant water heater. Yes, you sure can. When we moved into the house we're living at now, I gutted the utility room and I got rid of the tank water heater and I put in a small tankless unit. So we have two 40 amp breakers running that. Love it. Love it. It struggles to keep up if you have like two people trying to run hot water at the same time. So you gotta actually communicate. Like, hey, I'm taking a shower. Could you not? So, 50 and 20 amp lines, 120 volts. Here's the thing. 30 and 40, 50 amp lines don't run at 120 volts. They run like the Europeans do, 240 volts. So, same formula, amps times volts gets you watts. Somebody tell me, we'll use a clothes dryer as an example. You got a dedicated line. What would the wattage, we'll put it right here in the notes somewhere, wattage capacity be for 30 amp, and we'll use 50 amp down here. Wattage capacity. So we've got double the voltage, and we have higher amps in the lines. Go ahead and do those. I'll give you a minute, and I'll ask for those numbers. So you have 240 volts times 30 amps, and 240 volts times, we'll do 50 amps. All right. 30 amp, what's the capacity? Anybody? I saw some of you putting in your calculator, don't be shy. 7,200. 7,200 watts, that's as much as it can handle. What about the 50 amp? 50 times 240. 12,000 watts. All right, guys. Any electrician worth his weight in poop, I just made that up. I don't think that's the way the expression goes. Any electrician that's worth a darn will not design a circuit to be used to 100% capacity. Okay? There is a rule out there. It's called the 80% rule. In electricity, the 80% rule, let me check my camera, make sure I'm all the way over there, yes? The idea is do not exceed 80% capacity in a circuit, right, in an electrical circuit, full time. So if you're expecting to run an appliance that takes 5,000 watts and it's going to be running, full time, that's the thing you're running on there, don't run it on a circuit that maxes out at 5,000 watts. Because you're pushing it to the limit all the time. What's that going to do to the circuitry, do you think? It's going to wear it out sooner, right? If you're constantly heating up that wiring to its maximum over and over again, so it's heating and cooling all the way up to its capacity, it's going to wear out the insulation faster, okay? Other components in that circuit might break down sooner. I think that's why they have that rule. It's to prolong the longevity of the circuit. So it's an 80% rule. So, for example, our 30 amp circuit, I want you to do the math real quick. We can use up to 7,200 watts. Is it safe for it to jump up to 7,200 watts or close to it occasionally? Sure, but you're not designing it to do that. That's like the absolute limit. And then it trips, right? You don't want to be running above 80% capacity all the time. So, tell me this. What's 80% of 7,200 watts? Anybody remember how to do that math? How do you get 80% of 7,200? Or any number for that matter. You take the number and you... What's the decimal of 80%? 0.80, right? So you're going to multiply 7,200, in this case, 7,200 watts, go ahead, 7,200 times 0.8. What do you get? 5,760. 5,760. So if our 30 amp circuits in our homes are meant to run our clothes dryers, and the capacity is 7,200 watts, my guess is if we went home and looked at our clothes dryers, that little placard on them that tells you the electrical information, I could almost guarantee you, I will guarantee you won't see, if it's a 30 amp breaker it's on, or 30 amp circuit, it ain't running at 7,200 watts. It's probably running around 5,000 watts. If it's on high, it's probably drawing 5,000 watts. Is that a lot of power though? Think about that. You got a load of wet clothes, you throw in the dryer, usually in about an hour they're dry, hopefully, right? It takes 5,000 watts of power to do that. Now granted, usually it's not like running at full power the whole time. Usually it kicks on, right? Kicks on, kicks off a little bit, but 5,000 watts. What is 5,000 watts? Perspective. How many of you all have ever seen, maybe on the internet or maybe on a documentary or Bill Nye episode or something, have you guys ever seen these bicycles that they hook a generator to? Right? So you'll have somebody pedaling for electrical power. So if you had a world-class cyclist, whatever the terminology is, world-class cyclist, they'd be able to produce about 250 watts, unless they're in a sprint, right? If they were in a sprint, like pedaling as hard as they could for a short time, they might be able to exceed that. But a world-class cyclist, 250 watts is about what they could produce for like an hour at a time. Does that make sense? 20 times that much power to dry your clothes. Nobody's impressed. I got one person who's like, it is a lot. That's a lot of power. All right, the stove. Do the stove now. If it's on a 50 amp breaker, okay, 50 times 240 we said is 12,000. Well, we're going to assume that our engineers that designed that stove realize it's going to be plugged into a 50 amp breaker and they're not going to want to push past the 80% rule. So what's 80% of 12,000? 9,600 watts. So we'll round down again, just make it easy. Let's say 9,000 watts. What does that mean? It means your stove, how many burners are on top of your stove? 5 or 6? The really, really basic ones might only have 4. So 4 to 6 burners on top. Turn them all on high and turn your stove up to 400 degrees, 500 degrees. That's the max capacity, that range. All right. Guys, what questions do you have? Does this make sense? Does this help you understand maybe the power in your house a little bit? Let's do something else. How many of you guys have ever seen something that looks like that? What is that? That's a plug. It's the end of the plug, right? So your wall outlet, like that. Or it might be flipped over, right? Somebody first period, we almost started debating. It's like, no. So if you go on YouTube, you can look for hours at different videos saying it should be this way or it should be this way. It doesn't matter, y'all. If you look at the daggone thing with the cover off, there's print both ways because you can install it either way, all right? Good idea would just be consistent, but that is a 15 amp outlet. That is a 15 amp outlet. Plugs will plug in there and they won't be able to draw, because of the style of plug, they won't be able to draw more than 15. But if you have multiple things plugged in along the circuit, could you exceed 15 still? Yes, you could. So you still have to be careful. This one is for, you don't see these very often. In this classroom, we actually have true 20 amp outlets. And they look almost the same. But they've got this little side line. Does it have that back there? Does it? I saw those two do. These down here have it. Those are true 20 amp outlets. Now, have I ever seen someone that put a 15 amp outlet on a 20 amp line? Yes, I've seen that. That's not great. But won't cause you really any problems because you won't be able to plug a 20 amp thing into that. Okay? And the line can handle more than the outlet can. So that's okay. But if you have a 20 amp outlet on a 15 amp line, now that could cause some problems because when you plug in something that actually has a plug like this, it's going to draw more than a 15 amp line could carry. Does that make sense? Now what's it going to do if it tries to supply that much power?
Overheat.
It's going to trip the breaker. But what else have I seen? I've owned several homes. I've seen people, they want to have that so they can run their higher power circular saw or whatever it is. They'll switch out the circuit breaker for a 20 amp breaker, but what haven't they switched? The wiring. Like, oh, I'll put the plug in so I can use it. Oh, it'll trip the breaker. Well, I'll just replace the breaker with a higher rated breaker. Dude, the whole point is to protect the line, the conductor. You're overloading the conductor. Dummy, you're going to burn your house down. If you disable the breaker by putting a higher rating in on for the breaker than the line can handle, you're going to cause problems. So anyway, I've seen some shady stuff. My sister's house, when she bought that place, they had multiples, which used to be allowed, but it's not code anymore. There's reasons for that, but multiple circuits running off of one breaker. Anyway, yes, you sure can. What else can we do? We got about 8 minutes left. Trying to think, what have I missed? I got the 80% rule. I've got a picture on my phone to remind myself, and I'm using my phone to record.